Okay, so imagine you are writing a piece of software. You've been working on it for a while, the logic is completely sound, and it's running perfectly.
Right.
But then the very second you ask it to print just a single Chinese character, the entire system shatters. I mean, the code just entirely breaks.
Oh, wow. Yeah. That's a wild scenario to find yourself in.
Right. So today we are jumping into a deeply personal developer's journal. This is from March 18th, 2026, and we want to figure out why this one single line of text basically revealed a massive lie he had been telling himself about his own skills.
It's honestly such a fascinating deep dive. We're getting into the archives of qianmeng.org, which is
Right.
this incredible treasure trove of technical exploration. And the author, who goes by Ang, he just describes himself simply as an old software plumber.
I actually want to stop right there because, old software plumber tells us so much about the source material we're dealing with today.
Yeah, exactly.
Like, we aren't reading some polished corporate tutorial designed to sell a product. This is someone who literally spends his nights tinkering with free, Libre, and open source software.
Yeah.
Like the floss community.
Which is such a specific mindset. I mean, a plumber isn't focused on shiny fixtures or building castles in the sky.
Right.
A plumber is down in the muck.
Yeah, but-
They're looking at the literal pipes.
Yeah, trying to see where it leaks.
Exactly. They need to figure out why things leak, where the blockages are, and how the underlying infrastructure actually connects to deliver the final result. And that mindset is incredibly crucial for the journey we are taking today.
So the mission for our deep dive today is to unpack part 85 of Ang's notes on Haskell programming.
Part 85, just incredible.
It really is. And we are going to examine that specific coding error regarding the display of Chinese text. We want to see how it points to this massive universal lesson about the hidden dangers of convenience.
Especially when we're trying to learn a complex new skill, right? And, you don't need to be a programmer to grasp the gravity of his realization here. Whether you are learning a new spoken language or trying to master an instrument or just figuring out a new workflow at your job.
It applies to everything.
It really does. This journal entry fundamentally challenges the way we view shortcuts. It forces us to ask what we are actually sacrificing when we choose the path of least resistance.
Yeah, and you think a guy who is meticulously documenting his journey wouldn't be prone to taking shortcuts. I mean, we really need to establish the sheer scale of his documentation to understand why this specific failure hit him so hard.
The scale is honestly hard to wrap your head around.
It is. The archive on this site stretches all the way back to July 2011. And just to give you a sense of the volume, in the year 2025 alone, there were 730 posts logged.
Which, if you do the math, that averages out to 2 posts a day, every single day, for a calendar year.
It's a relentless output.
It really is. It's just nonstop.
It's like stumbling into the digital diary of a modern Renaissance man. Like, if you look at the project categories in the sidebars of the site, it is a monument to serial learning.
Oh, yeah. The sidebars are wild.
Right. You scroll down, and right next to notes on Haskell programming at part 85, you see notes on gardening up to part 839.
Part 839 of gardening notes. I mean, that is a level of dedication that most people don't even apply to their primary careers.
Totally.
He is out there logging the propagation of crown of thorns plants. He's noting down when he ends up with leggy seedlings. And the crucial thing is, he doesn't just throw the bad seedlings out and go buy fully grown plants.
Right. He analyzes them.
Yes, he documents the failure to understand how, the light and the soil interacted to cause that very specific result.
And that cross-disciplinary curiosity is just everywhere on the page. Notes on fish keeping is at part 210, complete with logs on betta spawning.
He's documenting everything.
Yeah, his diets, his home improvement projects, artificial intelligence, Elixir, Erlang, Rust, Go, guitar playing, even his meditation practice.
So we are looking at a highly documented, incredibly iterative learning process. He basically treats his own life as a series of structured experiments.
He really does.
He tries a new technique, observes how the system reacts, logs the data, and then adjusts his mental model.
Which brings us back to the code crashing. Because when a guy with this much methodical discipline, someone who is on part 839 of gardening, hits a wall in part 85 of his Haskell programming journey.
And dedicates an entire post to analyzing his own failure.
Right. We need to look at the exact mechanics of that wall.
Let's lay out the scenario he was facing.
Yeah.
So Ang was tinkering with a programming language called Haskell. And he was doing some basic data parsing using a very specific library called megaparsec.
Okay, so parsing, just to ensure we are all on the same page here, is essentially taking raw, unstructured input and analyzing it.
Yeah.
Right? So the computer can understand its grammatical structure and actually do something useful with it.
Exactly. And he noted that his setup was running smoothly. The code was executing just fine. The problem only popped up when he tried to display Chinese text from his parsing results.
So just printing the results to the screen?
Yeah. To accomplish this, he used a command called putstrln, which stands for put string line. He pulled this command from a specific module called data.text.io while also utilizing the standard prelude module.
And the code broke right there.
Yep, completely shattered.
And this is where I have to play devil's advocate for you listening because on the surface, this makes absolutely no sense.
That seems bizarre.
Right. If the logic of the code was sound and the parsing was working, why would changing the language of the output string suddenly shatter the entire operation?
Well, see, it didn't break the logic. What it did was reveal that the logic had never been strictly corrupt in the first place.
Oh, wow.
Yeah, Ang's diagnosis was that his code was executing, sure, but it wasn't pure.
But wait, it was running. He said it was working before the Chinese text was introduced.
It was working because of an illusion. He had a specific configuration setting turned on globally in his Haskell environment, which is called GHCI.
Yep.
This setting is a language extension known as OverloadedStrings.
OverloadedStrings.
Yes. And that extension was quietly bypassing the strict type checks that Haskell is so famous for.
Oh, I see.
It was allowing code that was fundamentally ambiguous to basically slip through the compiler and function seamlessly, until, of course, he introduced something complex enough to break the facade.
Okay, so to understand why this one extension caused such a catastrophic failure, we need to dive into the underlying architecture of how Haskell actually handles text, right?
Yeah, we have to look under the hood. Normally, in standard Haskell, a basic string like just the word hello is literally just an alias for a list of single characters. In the syntax of the code, it's represented as bracket char bracket.
Okay, so it's essentially a train with 5 individual cars, like H, E, L, L, O. And the system has to inspect every single car on the track.
Precisely. And computationally, treating every word as a complex linked list of individual character boxes is incredibly inefficient.
I can imagine.
It takes up a lot of memory and processing power, especially when you are scaling up to massive amounts of data.
So if I'm building like a massive enterprise application, I definitely can't afford to have the computer checking every single letter's train car. I need a bulk transport system for that text.
And that is the core of the issue. Professional developers rely on much more robust, memory-efficient formats, specifically types called text or byte string.
Okay.
But here's where the friction begins. If you simply type the literal word hello in your code, standard Haskell stubbornly assumes it's that basic list of characters.
The train cars.
Right. So if a function specifically demands the highly efficient text format, and you hand it a basic string, the compiler throws an error and refuses to compile. It demands explicit conversion.
Unless, of course, you enable the OverloadedStrings extension. Because from the source material, it seems like turning this on tells the compiler to look at a simple, literal, like hello, and automatically cast it as whatever type the function needs.
Yeah, whether that's text, byte string, or just a normal string.
It removes the friction of having to manually convert your data types.
It does. It handles it all for you behind the scenes.
So it's like having a universal power adapter. Instead of the system demanding the exact right plug, the basic character list, the extension just forces the connection to fit whatever text or byte string socket you're trying to use.
That's a great way to look at it.
You just plug it in, and the extension handles the translation in the background.
Let's actually push that metaphor a bit further, because it's less like a simple power adapter frying and more like using a universal translator device in a room where two people are speaking entirely different dialects.
Okay, I like that.
The device works totally fine for simple greetings, but when the conversation gets highly specific, the device panics because it doesn't know which dictionary to apply.
Which brings us directly to the Chinese text and the megaparsec library.
Exactly. Megaparsec is polymorphic.
Meaning?
That means the parsing library can output multiple different types of text data depending on how it's used. At the same time, the putstrln function Ang was using from the data.text.io module demanded strict, unambiguous text.
And overloaded strings are just sitting in the middle trying to guess what everything is supposed to be.
Yes. Because megaparsec can return different types of data, and overloaded strings makes the input type ambiguous by automatically adapting literals, the compiler suddenly lost its map.
Oh, wow.
Yeah, when the complex Unicode encoding required for Chinese characters was introduced into this ambiguous environment, the compiler didn't know which version of the text it was supposed to be translating those characters into.
It encountered type ambiguity.
Right. The compiler couldn't infer the correct path, so just threw an error.
So it wasn't that the Chinese characters were too heavy or complex. It was that the compiler realized it didn't actually know what data type it was holding.
And when Ang realized this, he took immediate action. I mean, he went right into his GHCI settings and completely disabled the global overloaded strings extension.
He unplugged the universal translator.
He did.
The source material actually includes the terminal output log of what happened next.
Yeah.
The very moment he turned it off, a flood of actual mismatch errors surfaced on his screen.
It's brutal.
Yeah, the foundational flaws in how he had structured his data types were suddenly completely visible.
The illusion of competence was gone. He was forced to look at the strict reality of his own code.
Okay, wait, I'm confused about something though.
Sure, what's that?
If overloaded strings is so dangerous and causes these massive blind spots, why does Haskell even allow it? Like, why build a make my code lazy button into a language that is widely known and respected for its strictness?
That is a great question, because for a veteran programmer who already has the entire architecture mapped out in their head, typing out explicit data conversions for every single string is incredibly tedious.
So it's a shortcut for the pros.
Exactly. The extension is a tool for advanced users who already possess the mental model of the system. It saves them time. The danger arises when a learner uses an advanced tool to bypass the fundamental lessons of the architecture.
Which perfectly sets up Ang's ultimate conclusion in this journal entry. He writes, very plainly, don't enable language extensions globally.
He recognizes that utilizing these conveniences during the learning phase builds deeply lazy habits.
Yeah.
You lose strict awareness of your own data types. You lose touch with the foundation of your own work.
He specifically notes that this is exactly why these types of convenience extensions haven't been voted into the official Haskell standard by default.
Right.
The designers of the language actually want you to be aware of the data you are manipulating. They don't want ambiguity baked into the core system.
If you truly want to understand how a complex foundation works, you have to face the errors early.
You can't hide from them.
No, because facing the errors is the only way to build an accurate mental model. When you hide your mistakes behind a convenient extension, or a cheat code, or an automated translator app, you aren't actually learning the system.
You are just learning how to operate the extension.
Precisely.
You are delaying the inevitable crash. Because eventually, you are going to encounter a problem like parsing a new language encoding that the convenience tool wasn't built to handle.
And when the crash happens, you won't have the foundational knowledge to fix it because the tool hid the mechanics from you the whole time.
It's basically the difference between memorizing a route on a GPS and actually knowing the layout of a city's grid.
That's a perfect analogy.
Like the GPS is a wonderful convenience that gets you to your destination faster. But if the battery dies and you've never paid attention to the street signs, the one-way roads, or the landmarks, you are completely lost.
You never actually learned the city, you just followed a blue line.
And this circles back so beautifully to Ang's whole persona as an old software plumber. Think about the gardening logs.
Oh, the crown of thorns plants.
Yes. When his seedlings get leggy, he writes it down. He embraces the friction of that failure. He understands that the leggy seedling isn't a punishment. It's feedback from the environment.
It is the biological system telling him exactly where his understanding of light and soil differs from reality. And the Haskell error message serves the exact same purpose.
It's feedback.
Yes. It is the compiler providing immediate, strict feedback on his logic.
We've covered a lot of ground here today. I mean, we started by marveling at the sheer output of a serial learner who documents his fish spawning alongside his deep technical explorations.
It's quite the journey.
And we followed him into the weeds of Haskell programming to see how a tool meant to make coding easier. The overloaded strings extension created type ambiguity that shattered his project when he introduced Chinese text.
And we arrived at a profound realization about the cost of convenience. Hiding from the strict rules of a system, even to save time, only makes you uniquely vulnerable when that system inevitably scales in complexity.
But before we wrap up, there's one last piece of the puzzle here. A detail from the periphery of Ang's blog. that I think completely reframes this entire story and elevates it beyond just a coding tutorial.
Oh, definitely. If you look at the Dole support section in the sidebar of his site, Aang lists the organizations he actively champions and donates to.
Right. He lists the Electronic Frontier Foundation, the Free Software Foundation, the Software Freedom Conservancy, the Tor Project, and Wikipedia.
Just consider what all of those organizations have in common. They are all fundamentally dedicated to systemic transparency.
Yeah, that's their whole mission.
They fight for open access to information, for the right to look under the hood of our digital world, and they actively fight against closed, proprietary systems that hide their inner workings from the end user.
So Aang's entire worldview is built on the belief that we have a right, and honestly a responsibility, to see how the pipes connect.
Exactly. He advocates for systems that are open and readable. It's the core of the FLOSS ethos.
Yet, in his pursuit of learning a new programming language, by simply flipping on a global convenience setting, that universal translator, he accidentally built a black box right in the middle of his own personal project.
He really did. He utilized a tool that actively hid the truth of his own work from himself. The system was smoothing over his errors, acting as a closed proprietary middleman between his logic and the compiler.
He basically went against his own deepest values without even realizing it, just to save a few keystrokes.
But to his credit, the moment he realized the system was lying to him, he tore it out.
Yeah, she didn't double down.
No, he disabled the extension, faced the raw mismatch errors, and documented the failure so others could learn from the mechanics of his mistake.
Which leaves us with a provocative thought to explore long after this deep dive ends. If open source developers, the very people actively building the transparent architecture of our digital world, are secretly relying on black box conveniences to get through their day.
How much of the technology we trust daily is just held together by universal translators waiting to fail?
Exactly. In our own pursuit of learning and moving quickly through the world, how many convenience extensions have we enabled in our daily lives?
And more importantly, what foundational errors are those conveniences secretly hiding from us?
Because eventually, the GPS battery is going to die. And we have to figure out if we actually know the way home.
We really do.
Thank you so much for joining us on this deep dive. We encourage you to keep looking under the hood, keep facing your errors early, and keep exploring the deep foundations of whatever it is you're learning today.